Hello there, it's Jason Gorman from Codemanship here with the third in our series on test-driven development in Java. If you've not watched the previous two videos, there'll be a link in the description below to the whole series. I highly recommend taking a look at that first. So in the first video we looked at the basic TDD cycle. You write a failing test, you write the simplest code to pass the test, and then if necessary you refactor the code to make it easier to change going forward. And in the second video, we looked at some good habits you might like to try getting into as you practice TDD that we found over the years make it more effective and more sustainable. In particular, we looked at how it's a good idea to start when you're writing a test with the assertion and work backwards from there. Start with the what and work your way backwards to the how. And we looked at why it's important to see the test does fail when the result is wrong. So see the test fail before you make it pass. And then we looked at how it works best in terms of writing tests that are going to be useful going forward as regression tests if each test only has one reason to fail. So when a test does fail, it's more specific about what's gone wrong. So you spend a lot less time in the debugger, or in the case of many experienced test-driven developers, almost no time in the debugger. In this third video, we're going to be asking a question that most developers, after they've been doing TDD for a little while, start to ask. And that's about what tests should I be writing? Because we could, for example, write tests for every method and every constructor and every class and every module and every function and every getter and every setter. And there are some developers who believe that's how it should work. But what we tend to find is when you write tests that are all about the details of the design, number one, that's putting the cart before the horse, if you like. That the whole idea of test-driven development is to discover the best design for passing tests rather than coming up with tests based on a design. But we also tend to find that we end up with a lot of very detailed tests that know a lot about the internal implementation. They know about the constructors and the getters and the setters and everything else. So the tests kind of stick to your inner design, a bit like melted cheese in a radio. You know, it's just everywhere over all the components of your design. So when you want to try and refactor that internal design, it becomes very, very difficult because you're supporting a lot of tests. There's a lot of code that depends on those details. So we tend to find that it's better to drive it the other way around. So the first thing we're going to be talking about today is what some people call meaningful tests. Meaningful tests. Let's use a requirement. Here's a requirement for a CD warehouse, so something that we can sell CDs from directly. Customers can buy CDs searching on the title and artist. So there's a couple of use cases there. Buying a CD and searching for a CD using the title and the artist. Record labels can send batches of CDs to the warehouse. So there's another use case. We need to be able to receive batches of CDs. Now, in test-driven development, we have found, many of us certainly, that it works best if you work directly from these requirements. So your tests should be about requirements. They should be about outcomes. They should be about outcomes that your end users want. Like, I want to be able to buy a CD. I want to be able to search for a CD and so on and so forth. So we're not saying I need to be able to test the getter for this or the setter for that. We're saying this test is about buying a CD. So a meaningful test. Now, that's not to say that we shouldn't think about the design up front. For example, we might want to sit down and sketch, here's a little UML class diagram based on those requirements that I think might be the classes and the main methods and some of the properties involved in these particular use cases. And it is useful to do a little bit of thinking about design up front, but don't get too attached to these. The mistake that I see a lot of sort of newbies to TDD do is they'll come up with a design and then they'll go, right, okay, we've got a catalog class. I need to start writing tests for my catalog class, tests for my search method. We've got a warehouse. I need to start writing tests for that. Oh, there's a stock item. We should write some tests for creating stock items. CDs, we should test the constructor of the CD class and so on and so forth. This is what I call design-driven testing. It's not test-driven design, it's design-driven testing. We thought of a design and now we're writing tests for parts of that design. As I said, this is the cart leading the horse. It's the wrong way around. We should start here. So no problem with people doing a little sketch or a sequence diagram or anything like that. It is good to have a little think about the design, particularly if it's a more complex kind of problem, because that can create a little roadmap for you. But really, we should start here with the requirements. So the second thing I want to talk about is a pattern from Kent Beck's excellent book, Test-Driven Development by Example. You'll see a link in the description below. And this pattern is called Test List. And say what you see. It is a list of tests. So we're going to go through these requirements and we're going to think about the test cases, the test scenarios we think our code will need to handle. Starting with the first use case, which is buy a CD. Okay. Now, let's think about the cases here. Well, first of all, there's the happy path, if you like, and that's where the CD is bought. So let's talk about our happy path. What we're saying is the CD is in stock. We have sufficient stock for this, so we can buy a copy of this. And let's think a little bit about the outcome here. Well, then the stock count is reduced by the quantity that we're buying. So if we want to buy 2 copies of Bat Out of Hell by Meatloaf, and we've got 10, then we should end up with 8. Now, we're kind of feeding in a little here into the customer collaboration process. If we're doing this process of thinking about test cases, it's a really good idea to actually sit down with our customers and reason about these test cases with them. So using examples, real examples with them. Okay, well, let's use the example of Bat Out of Hell by Meatloaf. Let's imagine we have 10 copies in stock. Let's imagine we're buying 2 copies. Therefore, what should the outcome be? So if you're doing, for example, what's called behavior-driven development or specification by example, this is normally where we would have this conversation and we would come up with our list of tests. Now, I'm doing this very informally. I'm not capturing test data here. But if you want to capture the actual examples, we find that works very, very well because it eliminates any potential for misunderstandings if you use a concrete example. So highly recommend looking out there on Google for behavior-driven development and specification by example, because that's a great source of these kinds of test lists. And these are the tests that our unit tests are going to be about. So our first test is going to be about what happens when the CD is in stock. But what happens if we have insufficient stock? So we've got 10 copies of Bat Out of Hell and we're trying to buy 11 copies of it. So what happens then? Well, we might throw an exception, for example, that our client code, our UI, would then have to handle. Okay, so that's buying a CD. There's a couple of test cases we need to think about there. What about searching for a CD? Okay, well, the obvious, again, the happy path is it's in our catalogue, in which case we return the CD info. So that if there's a CD class, we'll return that if it matches. And what happens if there's no match? In which case we would return nothing. And what if actually we've got multiple CDs with the same artist and title? So you can imagine, for example, that there are multiple versions of Bat Out of Hell. It's been released several times and in several different versions, if you like, remastered and so on and so forth. So there might be multiple versions of this. So we might have multiple matches, in which case we would return the list of matches. Okay. And what about receiving stock from a label? Not stock, Jason. Receiving stock from a label. So we would say, okay, well, let's imagine it's a single title and that's in the catalogue. In which case we would add the copies received to that CD. And what happens if it's not in the catalogue. In which case we would add it and add copies to stock. And then finally, what if our batch is actually multiple CDs? So 10 copies of Bat Out of Hell by Meatloaf, 50 copies of Kill 'Em All by Metallica, and so on and so forth. So any new CDs added to catalogue and stock added to each CD. So we've got a bunch of test cases in our test list that we might want to think about now. And this provides a useful roadmap for how we're going to tackle this problem in a test-driven way. So we're going to go through this list. Typically, you would start with what you think is the most interesting or the most important or the most valuable or the highest risk particular scenario, the one that we would get the most value from as a customer or that we would learn the most from as developers in terms of design. So we're going to tackle them in this order because I think if you're selling CDs, maybe the most important scenario is where we can actually buy them. Customers can buy them. So we're going to take that as the most important test case. So let's do that one first. So we're going to start, it's test-driven development, by writing a failing test for buying a CD that's in stock. Let's create a Java test fixture for that. And we'll call that buy CD test. Okay, now, in order for me to make this a JUnit test, I'm going to need to, let's open my module settings, and we'll add JUnit. This might take a while depending on how fast Maven repositories are today. So let's just search, well, it's JUnit. Let's just search and see what that is. Crank the handle, Maven. There we go. We're going to use JUnit 4 because I'm a big believer these days in hanging back when it comes to new versions of tools. Looked at JUnit 5, it's great. It's got some great stuff. But you have to, with these kind of tools where there are a lot of other tools and frameworks built around them, I find you sometimes need to wait a year or two for the ecosystem of those tools and frameworks to catch up with the new version. A good example of that in .NET, for example, is how NUnit has only just recently got a version that supports .NET Core. So I'm waiting just maybe a little longer for the ecosystem of tools and frameworks to catch up with JUnit 5. It will get there soon enough. Now, okay, let's write a test. And we're going directly from our test list here. So let's go back to our list. Buy a CD when the CD is in stock. So that will be a good name. CD is in stock. So we're naming our test after the scenario. And we're going to write the assertion first and work backwards. And what we're saying here is that, let's say we have 10 copies of a CD. We buy one, so we should end up with 9 copies. Now, what's happening here is you can see that we're beginning to discover a design that's kind of like this. In actual fact, they're calling it stock count. Doesn't matter. Actually, yeah, let's call that get stock count. So this can be useful when you have a design to be able to refer back to it and say, well, what should I name this class then? But notice that I'm discovering it as I'm writing the test. Oh, I need the ability to find out what the stock count is. Okay, let's do some yak shaving here. Let's import that. Let's declare our CD. Compact disk. Whole words. I'm a big fan of whole words. There we go. And back to our CD test. New compact disk, and I think what we'll do is we'll say in the constructor, okay, you're being created with 10 copies. That seems a handy way. So now again, we've discovered this class compact disk, and we've discovered that it needs a constructor. So let's declare that. So we are driven directly from what we've agreed with the customer should happen. Let's call that initial stock. That seems like a good name for it. So driven by what we agree with our customer should happen, when we came up with that list of test scenarios, we're now working backwards and discovering that we need this design. And the details of the design that we end up with, let's buy one copy. The details of the design that we end up with are being driven directly by this process. This is what we mean by test-driven development, by test-driven design. That the test case is telling us this is what you need. Okay. Quantity. How many quantities are we purchasing there? And I have a feeling, yeah, that's not the compile unless we return something. So let's return something there. Okay. Back to our test. There you go. So there's our test. We set up a CD with 10 copies. We buy one copy. And then we check that the stock count at the end of that is 9. Let's run that test and make sure that it does indeed fail because the stock count is wrong. There you go. Expected 9, but actually 0. And now we need to do something to make this test pass. Now you will have seen, if you watched the first of the videos in this series, that we took baby steps. So we did an example of a shopping basket. And we took sort of baby steps in terms of fleshing out the implementation of that shopping basket to calculate the total of the items in the basket. So we started by just returning a hard-coded value for what the total should be in an empty basket. And we could do that very easily here. Let's go back to our test. And then we could add more test cases for buying a CD. This is a process that Kent Beck in his book describes as triangulating. We triangulate a design one example at a time. So you might start with the simplest example, then just return a hard-coded value, and then another example, and maybe that becomes a field, and so on and so forth. So it kind of, as you add more and more tests, your implementation gets more and more general as you flesh it out. But sometimes that process doesn't really add any value. And this is the third thing that I want to talk about. What happens when the implementation is obvious? Do we need multiple test cases for reducing the stock count of a CD? I don't think we do. So what I'm going to do is I'm going to create a field for initial stock. There we go. And I'm going to just rename this field. Oops. Let's just call it stock. Okay. And then we're just going to return that. Oops. We've already written that word. Let's just return the stock. And here all we need to do is it's final, so we can't have it final. That makes sense. Okay. Of course, if we were doing functional programming, if we were having a mutable state, we'd return a copy of the compact disk with the stock changed. But I'm going old school here. This is old school OA, where we're going to mutate the state. Okay. So now we've got it passing. We've got an obvious implementation. All we're really doing is changing the value of an integer field. So it's what we call an obvious implementation. So I've just gone for it because I think to have multiple tests for doing that wouldn't really be adding much value in terms of design or in terms of tests. So when the implementation is obvious, just go for it. Don't triangulate. Don't think, well, I need to do multiple examples and start with a hard-coded value. If you're, subtracting from an integer or returning the value of a field, or if you're adding an item to a list, you can probably just write the code for that and don't worry too much about triangulating. It's only when you think, actually, this is not so trivial, that you should triangulate. Let's do one more test case just so you can get a feel for how this process works. So again, it's a meaningful test. So we're not going to go, right now we need to write tests for what else is in our diagram here. We need to write tests for a batch or something like that. No, we just go straight to our test list and go, what's next in the list? I'm just going to cross this one off the list. There you go, that one's done. And what happens if there's insufficient stock? So we'll write a test here that's expecting an exception to be thrown. Insufficient stock exception. There we go. And so again, we've decided by writing the test, we're going to need one of these. So let's create one of those. Extend throwable, lovely. And now we're going to, all we need to do now is create a CD. Let's give it 1 copy. Let's give it 0 copies actually. And we're going to try to buy 1 copy. Okay. And annotations are not allowed here because that is not a method. Silly JSON. Public void insufficient. Must be a Friday. My fingers are not working today. Okay, there we go. That's why it wasn't compiling. Right, okay, let's run our tests again. And this will fail because that exception is not being thrown. And we should not expect any other reason for that test to fail. We want to know that it does fail when the exception is not thrown. Test your test. Okay, and now when we buy, again, obvious implementation. So if our stock is less than the quantity, we throw this exception. Okay. And it's probably going to say you need to in which case that's going to break a bunch of stuff here. Let's add. I should probably have made this. Yes, we knew. Okay, maybe that wasn't quite such an obvious implementation. A little quirk of Java there. So we've done a couple of tests. We crossed the next one off our list. And we worked through our test list, one meaningful test at a time, crossing them off, discovering the design. It is absolutely fine to have a little think about the design up front, but really, it's okay to think ahead. In fact, I highly recommend it, but we don't want to code ahead. When it comes to the details of our design, we let the tests and the test-driven development process take care of those details. So we're not writing tests specifically for getters and setters and constructors. We're writing tests for meaningful outcomes, things the end users want to happen. So there you go. There's meaningful tests. Write tests that are about what the end user wants, not about the details of your design. Test lists are a really useful kind of roadmap for planning the work, but also it is a good exercise actually to sit down with our customers and think about the test cases and capture those. And if you're a fan of behavior-driven development and specification by example, then that means capturing real examples, real test data with your customer that we can then feed into our tests. And that could be a very powerful requirements analysis and specification technique. And far beyond the scope of this particular series. And then finally, sometimes when it comes to how many tests we should write and how detailed and how small the steps need to be, sometimes we should just go for it. Sometimes the implementation is obvious and we don't need to write a whole bunch of tests for buying a CD that's in stock. Maybe one will do because the implementation is obvious. And you will often find with experienced test-driven developers, they write a lot less tests than less experienced developers. It's often commented on. In fact, if you go look at my GitHub profile, if you go look at, I'm just Jason Gorman, all one word, on GitHub, you'll find that I've got a few sort of sample projects of things, little little proofs of concept that they've done in a slightly test-driven way, and you may be surprised at how few tests there are compared to how many you might be writing if you're just starting out. So, write meaningful tests, make lists of them with your customer, capture real examples if you can, really, really handy, and let those lists serve as a roadmap for your work. And don't worry if you think of new test cases while you're working, just add it to the list. And then finally, sometimes we don't need to triangulate. We can take slightly bigger steps depending on how obvious that implementation really is. But one caveat, if you're new to TDD, maybe be a little careful about taking leaps. Sometimes we overestimate ourselves when we're not as experienced with something. So there you go. That's video number 3. I will see you in video number 4.